Early in the 20th century, these motion pictures of the great white fleet of the United States Navy were seen throughout the world. Here, years earlier, President Theodore Roosevelt comes aboard the Kearsarge. Roosevelt's personality became familiar around the world with the help of the motion picture. Motion pictures such as these of the first race for the Vanderbilt Cup were exciting novelties in 1903. Only a handful of years earlier, motion in pictures was only a dream. This film will describe some of the events leading to the perfection of motion pictures. Down through the ages, man has sought to record his deeds and his actions in art. First, on the walls of his cave dwellings. Later, in relief on the walls of his temples. Although man could record the impression of motion in his art, he could not reproduce motion for the unimaginative spectator. In fact, only an artist could record pictures at all. The Florentine genius Leonardo da Vinci, whose Mona Lisa alone immortalized his name in the arts, documented the phenomenon of the camera obscura, a dark room in which anyone could trace the outlines of nature. The camera obscura, the basic instrument of all photography, was used as early as the 11th century by the Arabian astronomer Al-Hassan, who employed it in the study of eclipses. Giovanni della Porta, a 16th century Neapolitan writer, entertained guests with natural magic, as he called his application of the camera obscura. In a way, he was the first projectionist. However, that title may belong to Athanasius Kircher, a 17th century German priest and scientist, who developed this catoptrican theater, a theater of mirrors, using sunlight to reflect pictures on a wall. Kircher's book, Ars Magna, Lucis et Umbrae, or The Great Art of Light and Shadow, was published in 1640, and again in this edition of 1671. In it are several illustrations of what he called magic lanterns. Historians differ as to whose magic lantern came first, but Christian Huygens, a Dutch physicist, made his in 1656. Here was a means of projecting drawings on a wall for many people to view at once. Magic lanterns were made in many forms and for many uses. This is Johann Zahn's device, a clock. This one is a wind indicator, connected to a vane on the roof. As though in prelude to the perfection of motion pictures, Peter Mark Roget, an Englishman famed for his thesaurus of English words and phrases, read a paper in this room before the Royal Society of London on Christmas Eve, 1824. His subject was the persistence of vision with regard to moving objects. But it was Dr. John Ayrton Paris, a year or so later, who demonstrated the theory graphically with his toy he called the thaumatrope, or wonder turner. Persistence of vision made the images on both sides of a card appear as one. In 1829, the Belgian scientist Joseph Plateau developed a machine which caused a deformed image to look normal when viewed through a spinning disc or shutter. Plateau continued experimenting, and 4 years later presented this device, the phenakistoscope. Almost simultaneously, an Austrian geometrician, von Stumpfer, presented a similar device, the stroboscope. They came to be known as Plateau-Stumpfer magic discs, and with changeable picture wheels, gained favor as parlor entertainment. Employing the same principles, the zoetrope rose to popularity, and artists drew action strips by the hundred, so the viewer could change pictures at will. A refinement of the zoetrope idea was the praxinoscope, developed by the Frenchman Charles Reynaud. An Austrian artillery and ballistics expert, Baron General Franz von Eucatius, devised this magic lantern, which used a variation of the Plateau-Stumpfer magic discs, rotating a glass disc behind an aperture and shutter to produce the first motion pictures projected on a screen. Meanwhile, Louis Daguerre perfected a process he and Joseph Niepce had developed, a method of recording a picture by chemical action on a metal plate, the daguerreotype. Another process of the same era was the Calotype, or Talbot type. The paper negative at left, used to make a positive print, was developed by William Henry Fox Talbot in England. Coming closer to the needs of the motion picture, the Langenheim brothers of Philadelphia made positive prints on glass plates, making projection of photographs possible. It is significant to mention that by 1870, men knew of persistence of vision. They had a variety of apparatus for projection, and they had transparent photographs of quality. All that was lacking was motion. Leland Stanford, the former governor of California, had a large farm and an interest in the way artists were depicting the gaits of horses. To satisfy his curiosity about the horse in motion, he engaged the San Francisco photographer, Edward Muybridge, who came to the farm in 1872. Muybridge made many pictures in the next few years, but they were inconclusive. Stanford then brought a railroad engineer named John Isaacs to the farm to help explore the idea of using several cameras instead of only one or two. Muybridge and Isaacs set up a series of 24 cameras whose electric shutters were tripped when threads were broken by the horse as it ran past the cameras. Each camera made an exposure of 1/2000th of a second. The cameras were so spaced that only 1/25th of a second separated the exposures. In 1880, Muybridge devised this projector, similar to the Eucatius machine, and dubbed it the Zopraxiscope. With it, he showed his pictures to the San Francisco Art Association, the first exhibition before an audience of projected photographic motion pictures. Muybridge's exhibition caused a sensation in the press. He showed his pictures all over the United States, and in the following year took them to France, where he showed them to the physiologist Etienne Jules Moret, a pioneer in the study of animal locomotion and photography. In this so-called physiological park, where Moret used many instruments in his studies, he saw the need for a single camera, which would photograph separate pictures in quick succession. He developed this photographic gun, which made 12 pictures on a glass plate. This was approaching the solution.